Measuring of understanding statistics before and after this course. Okay, what kind of data have we got here? Turn to the person next to you, tell them what you think, and if you have the same answer, you're probably right. Okay, is this nominal or interval? Okay, hands up those people who agree with each other. Okay? What's the answer? Person in green again. Ordinal. That is correct, okay, because if you think about it, a measure of understanding statistics is going to be a mark. We could do it like a mark out of 100 or something like that. It's not a yes, no. Do you understand statistics, yes or no? Well, I guess you could try that, but it's not really very helpful. Okay, now, how many samples do we have here? And this is sort of a trick question. Okay, how many columns of data am I going to have here? Hands up if you think 1. Hands up if you think 2. Good. Okay, we've got 2 columns of data. Therefore, we're going to be comparing 2 means. But here's the question. Is it paired data or is it independent samples? Okay, turn to your person next to you. Decide whether it's paired or independent. Okay, hands up if you think it's paired. Well done, it is. Okay, why is it paired? Amelia? Because it's before and after, and it's the same people before and after. If I had taken some people who haven't done the course and some people who had afterwards, it wouldn't work. It's the same people. So it is the paired test of population means. So what we've got there, we've got interval ratio data. We have one sample, really, with 2 measures. And this is where it gets a bit confusing because it looks like 2 samples, but really it's one lot of people and we're measuring them twice, before and after. But it actually is 2 columns in Excel. And that one always has to be given in 2 columns because it matters what order they go in. The order of the second one has to be the same as the order of the first one. You can't just sort of randomly check one lot and then randomly check another. It's not paired. Okay, so can anybody tell me what statistic we're going to get from that? This is a nice easy one in Excel. We're going to get a t statistic and then we're just going to have a look at our p-value, and if p is low, null must go. Okay, next one. Time spent shopping under 30s versus over 30s. Okay, turn to the person next to you and see A, B, C, D, E, F, G. Which one do you think it is? So time spent shopping. Okay, Ben, what do you reckon? Which one can't you see? Time spent shopping. That one. Oh, I see. Okay, time spent shopping, under 30s versus over 30s. Okay, is it interval data or nominal data? Hands up if you think interval. Great, we're getting there, you're right. Okay, 1 sample or 2? 2, that's correct, yes. Okay, time spent shopping, so it's A. Did we never get A? So it's time spent. We've got 2 independent samples. We've got a group of people who are under 30, a group of people who are over 30, and we ask them, how long do you spend shopping for Christmas presents? And so you're going to get a whole lot of numbers, and you find the means, and you compare your means. So we have interval ratio data. And the number of samples is there are 2 samples. You've got 1 over 30 and 1 under 30. The output is again a t statistic and a p-value. It's a bit of a recurring theme here. Right, now let's try, what about this one? Do products meet the minimum standard? Okay, so we've got chip packets And we're trying to see, have they got the right amount of chips in them? Do they weigh the right amount? Do they meet the minimum standard? Okay, so we've got to decide what kind of data is it and how many samples and what are we comparing with? Okay, can you decide between you? What do you think, is it going to be C, D, F or G? Okay, Ed, what do you think? You're Ed, aren't you? Yep. Yep. No, person two back from you. Yep, what do you think? No? Okay, one in front, what do you think? Okay, anyone got an opinion? Have you talked to somebody? Have a think about it. Okay, we'll give you a little bit longer. Do the products meet the minimum standard? We're talking about chip packets, we're talking about weights. First of all, what kind of data is it? We've got some nominals. Do we have any intervals? It's interval data. We're going to weigh our little chip packets and see if they weigh the right amount. That's a number. It's not nominal. It's not yes, no. It's saying, do they meet the required standard? So notice I used the same example, the chip packets, because just because it's chip packets, it doesn't mean it's nominal. I don't want you starting to use that kind of thinking because it's not going to work you in the real world. Okay, and we are testing it against a value. We are simply looking at the mean weight in the chips in the packet, and we're comparing it with the standard, which might be, say, 100 grams or 150 grams. So it's the test of a population mean, and it could be one or two-tailed. Okay, do you think that's going to be one-tailed or two-tailed? Okay, do we care if there are too many chips in the packet? Well, it's hard to know, really. We may or we may not. I think it's more important that we have enough. I would say that's probably going to be one-tailed. If it doesn't say it, it won't ask. So, oh no, it does say, do the products meet the minimum standard? So therefore it is one-tailed because we only care about whether there are enough chips. We don't care whether there are too many chips. So that would be one-tailed, that one. So that's interval ratio data. So we could have, say, weights or something like that. And this is what you need to do. You need to put this away, get a clean one and try it yourself. Make sure that you can answer these. Number of samples. How many samples have we got? Hands up if you think it's one. Hands up if you think it's two. Okay, lots of people not thinking. Turn to the person next to you, decide between you, one or two. Okay, I heard a one from there. It is one sample. Okay, we're comparing with a value. We're not comparing two samples against each other. Okay, and we're going to get our t statistic. And guess what? A p-value. And this is what I'm trying to show you here, is that basically if you can work out what test needs to be done and you understand the p-value, an awful lot of things can become clear.